Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 39, Thermodynamics, Part 1. Here are our objectives for today's video. Pause here. So this probably seems kind of arbitrarily simple, and that would be fine for it to seem that way, but we just want to have clear-cut definitions before we start talking about thermodynamics. So when we're talking about a system, we're talking about typically usually a calorimeter, so whatever it is that we're studying, and then the surroundings is literally everything else in the entire universe. Pause here. So we've discussed enthalpy, but we haven't yet discussed entropy, which is sort of a sometimes competing, sometimes helping force when it comes to thermodynamic favorability. So entropy is a measure of how much randomness, how much disorder is in a system. Or there is actually a mathematical relationship for this that you really don't need to know for the AP exam, that the entropy of something is directly related to the natural log of the different numbers of ways that the atoms can be arranged. That doesn't really matter. What you do need to know is that it is if something is more disordered, meaning there's more ways for something to exist. So gases tend to be more disordered than liquids, which are more disordered than solids. Then that would have higher entropy. That what I just said about the natural log thing, that's the reason why the entropy of a perfect crystalline substance at 0 Kelvin is also 0, because there's only one possible way for those molecules to exist, and the natural log of 1 is 0. You really don't need to know that, though, by the way. Pause here. Okay, I'm going to wait about 5-7 seconds and then say the answer out loud. So the molten NaCl will have higher entropy. If something's a liquid, there's more randomness. Graphite is less of a rigid structure than diamond, so graphite is more disordered. And then at 0.10 atm, there's more possible ways for the gas molecules to be oriented, as there's more space for them to move about, so they will have higher entropy. Pause here. So thermodynamic favorability, that's like the modern way to say it. Spontaneity, sort of the older way to say it. I learned spontaneity in school and then later switched over to using the term thermodynamic favorability. You'll hear me using both. It's just a measure of if something will occur or not without outside intervention. It doesn't have anything to do with rates. So for example, the conversion from carbon to diamond is technically spontaneous, but the rate is so low that it effectively isn't. So it just means, will the reaction happen, will it not? Pause here. An increase in entropy can make a process more thermodynamically favorability. We'll see in the next video that there's two other factors that we need to consider, enthalpy and temperature, but we'll hold on to that for the time being. Pause here. I'm going to wait about 5 or 7 answers, and then I'll say the answer out loud. So delta S, that's final minus initial. So if it's more disordered later, that'll be positive. And if it's less disordered later, it'll be negative. If I'm dissolving a solid in water, it's an increase in disorder. So delta S is going to be positive. And then water condensing on the surface of a cup, it's going from gas to liquid. So that is going to be negative. Here are the practice problems associated with today's video. Thank you so much for watching and have a great night.